Hello students. In the last class we are discussing regarding different terminology, different terms used in thermodynamics. Today we will discuss some different physical quantities that is we will use in thermodynamics. How these quantities are interrelated to one another and what are the significance, what are these expression, what is calculation, we will discuss today's lessons. So let us start. We know that is work done. It is also one important physical quantity, that is work done. Work, it is one important expression of energy that related to the change of a system, displacement of a system in the direction of force. Already know that work will be done when the system will be displaced in the direction of force. Here force deals with the change in the distance. This calculation that work is force into distance, that is indicates work. But this type of work we can say is a mechanical work, that force into displacement, the direction of force. Displacement should be in direction of force, then you get the work done. Work done is also called as organized form of energy, so that work done will be maximum. It indicates that maximum energy gained by the system. So we can say it is an organized form of energy. Work is called also organized form of energy. Organized form of energy, that is also called work. And different types of work will be done. That one work is also called electrical work. Electrical work means it is expressed as some change in potential and amount of charge used. The multiplication of potential and charge will give the electrical work done. EMF, how much EMF is produced and how much charge is also involved. This multiplication, each product is also electrical work done. But another work done, that is you can say mechanical work done, that is work of expansion. Work of expansion. Work of expansion, that is also type of work. And generally, for particular, when the system work is done, we can say we can derive work from the system by the use of the system, or work is done on the system. Work can be done in two ways, that is work by the system, that is always considered as positive work done, always positive, it is negative. Work done by the system, that means always negative. It is a negative work done. And another work on the system, that is, we can say it is positive work done. Work done by the system, it is also called expansion. It is also called expansion. Expansion. And this is called contraction. Gas can be expanded, gas can be contracted. Contracted means volume is decreased, expansion means volume is increased. So work by the system is a negative work done. We have to remember that the sign of convention. Work on the system is positive. So you have to remember this. Let's consider, suppose the work of expansion, if gas is kept in a cylinder, gas in a cylinder fitted with a piston. So this is your gas. Kept in a cylinder fitted with a piston. So when the piston weight is 0, that means weightless piston, its weight is considered as negligible. So what happens if you give the pressure on the piston, then it will be moved downward. That is called work done on the system. If you give pressure, that is called work on the system. If work will be done in this way, this is your piston. If we move upwards, means the external pressure is low pressure. If low pressure, that is gas will be expanded, that is called work by the system. When this case will take place, so what happens? Piston will move upward, it will be moved to this point. So this is your volume V1, this is your volume V2, and the displacement in the direction of force, that is dl. Let it be small change in displacement, that is dl. So we know that in mechanics, the work done will be pressure into volume change. As it is work done by the system expansion, it is a negative sign, considered a negative sign. It is a sign of convention. Work done by the system means negative sign. What is P? P is the external pressure. Here the pressure is lower than the gas. The gas has pressure and piston has pressure. When the pressure of the gas will more than the piston, then what happens? Piston move upwards. That is called expansion, and here that work done is considered as a negative sign. But when for the whole change, when you calculate the total expansion V1 to V2, if you will calculate total volume, with small change is taken as del. For small change in volume is dV. For whole change is considered total work done by the system. This change is considered as a reversible change. This is considered as a reversible change, isothermally and reversible. Work done by the system reversibly and isothermally. Here is a isothermal change and reversible. Reversible means very slow change, small displacement, repeatedly. First you bring the small change, then again small change, like this. That is called reversible and slowly. And condition is isothermally, temperature is constant. In this case, temperature is constant, only there is change in volume at particular pressure. So work done will be minus P into del V. So if you calculate the work done, total work done by the system reversibly and isothermally will be what? W will be integration of minus P del V. Then what happens? Here volume is V1 to V2. Then what happens? P will be outside because it is constant, and del V, integration of del V, PV. If PV is this much, so P and del V, here what we can write, that P you can write in this way, that P is, we know PV is equal to nRT. So what is the value of P? P is equal to nRT by V. So you can put here P is equal to nRT by V and del V or VV. The integration minus and V1 to V2. Then what happens here? We know integration 1 by V, integration of 1 by V with respect to V is what? Minus remain 2.303 log. Here N and nRT both are constant because at isothermal condition means temperature is constant. So 2.303 log, then nRT. Then here what? Integration will be log V. Volume is here V1 to V2. Then if you write this one, then what is the value of W total work done will be minus 2.303 log nRT. You can write here, nRT will be constant, you can bring this side. Here, as it will not be used here, you can bring it to left side. Here, you can write that this equation clearly written as here minus nRT log minus 2.303 nRT, then log V, then limit is V1 to V2. So minus 2.303, then nRT, that is nRT, then log here V2 by V1. So this is the final derivation work done by the system isothermally and reversible. So W is equal to minus 2.5. So W is equal to minus 2.303 nRT log V2 by V1. But we know P1 V1 is equal to P2 V2 implies V2 by V1 is equal to P1 by P2. So we can put this equation as what? Minus 2.303 nRT, then log P1 by P2. So we can write different equations. This is the derivation of work done by the system isothermally and reversibly. So this is the calculation of work done by that is called work of expansion. So this work done is related to expansion. But if there is a condition, if the del V is 0, if del V is equal to 0, there is no change in volume, or another case, if P external pressure is equal to 0, there is no external pressure on the piston, there is no pressure, then what happens? That means gas is kept in vacuum. That means the system is discussed will be considered in a vacuum, there is no pressure. So P external pressure is taken as 0. So P external 0 means in both cases W is equal to 0. That means no work will be done when there will be no change in volume or there is no external pressure. That means gas is expanded in vacuum without under pressure. Or there is no decrease in pressure, there is no increase in pressure. In that case, that is, we can say the free expansion. Free expansion means the P external is 0. That means W equal to 0. No work will be done. This is very important condition of the calculation work done in free expansion of the ideal gas. So it is, that is, system means it is ideal gas. This is for ideal gas. Expansion of ideal gas reversibly and isothermally. This is the work done. So this work done is called reversible work done. But one thing remember, work done reversibly is always greater than work done irreversibly. So this thing also remember. Always reversibly means slowly and very taking the small change in volume. The work done, if the total work done will calculate the result, the work done, total work done for the reversible change will be more than the irreversible. Irreversible change means you have to take as a whole, initial to final. But small change when it takes place during the process, we will calculate for every change, the work done for every change of displacement, total displacement. For total displacement, total work done will be always greater than the irreversible. So this is very important condition. Reversible work done isothermally always greater than the irreversible process. So this is regarding work done. Then another important term is heat. That is heat. Heat also, that is symbol written as Q. Heat also, it is already we have discussed this work done is an what? Not a state function. Not a state function. Already I have discussed. Because it does not depend upon the path. Sorry, it depends upon path. As it depends upon path, so not a state function. If the physical quantity, in the last period I already discussed, if physical quantity that only depends upon initial value and final value without the path of progress, that is called what? State function. It does not depend on the path. As work done depends upon the path, that's why it is called what? Not a state function. And heat is also one, we can say, it is also one extensive property. Extensive nature. That means the amount of heat depends upon the amount of mass. Okay, and this heat may be positive or negative. Observe heat, when heat absorbed is considered as positive. That heat is considered positive. When heat will be evolved, that is negative. Heat produced means negative, heat absorbed means positive. So this is a sign of convention regarding heat. And heat mainly indicates that the exchange of energy between two systems where there will be difference in temperature. When there will be two systems, suppose A, suppose this is B, there will be exchange of heat. Suppose heat will flow from A to B. That means A having more temperature, B having lower temperature. So heat will be transferred. It is one mode of energy. Heat is also one mode of energy. What is one form of energy where it moves, it then exchange between the system and surrounding. Between system and surrounding, the heat exchange takes place due to difference of temperature. So it is one mode of energy, that is heat. It indicates the difference of temperature of the system and surrounding, or between two systems also we can say. So heat is transferred from higher system of higher heat to the what? Surrounding of lower temperature, lower heat. So higher heat to lower heat, That means higher temperature, lower temperature, always heat transfer. And heat is also an extensive property. It is one extensive property. It is measured. It can be converted to different energy. Either chemical that it can convert to potential energy. It can be converted to work done. Depends upon the what that conditions. So heat is also one extensive property, and heat absorbed is taken as positive. Heat evolved taken as negative. Then another important term we will discuss, that is very important thing, that is internal energy. That is internal energy. Its symbol is E or U. Either E or U. That is called internal energy. Internal energy, it is also one that extensive property, extensive nature, that means depends upon the mass, and it is also a state function. It is also a state function. Okay, and the internal energy of the particular system is sum of, you can see E is the sum of all kinds of energy. It possesses all kinds of energy: vibrational energy, rotational energy, potential energy, kinetic energy. So many types of energy possessed by the system is equal to internal energy. So as the sum of all types of energy, so the absolute value is very important. Absolute value of E cannot be determined. Absolute value cannot be determined because the actual value of energy possessed by the system we cannot calculate. That's why absolute value cannot be calculated. But the change in internal energy, that is daily, is equal to final minus initial. It is equal to, in the form of heat change takes place. In the form of heat change takes place at per degree change in temperature at constant value. Okay. What is the change? You see, absolute value cannot be determined because absolute value is not possible, because all types of energy cannot be determined with accuracy. So, but change in internal, suppose when the system undergo change in internal energy, when the energy will be changed, then it can be calculated in the form of how much heat change took place. Suppose heat will be absorbed or heat will be evolved, but for a degree rise of temperature. Suppose you increase 1 degree temperature, then how much heat change takes place? You just increase 5 degree temperature, then how much heat change takes place? That means heat will increase. When temperature increase means heat will increase. That this difference of heat change, amount of heat absorbed or amount of heat evolved by the system for degree rise of temperature or for degree fall of temperature, but condition at constant value. So, each internal energy change value can be calculated at constant value. Value must be constant. And this is also an extensive property. It is also a state function, and it only depends upon initial value and final value. That's E2 minus E1. That is called change in internal energy. This is regarding one important physical quantities. Its energy is unity same as energy, heat unity same as energy, that is kilojoule. Here also kilojoule or joule, work done also kilojoule, calorie, like this, same unit. Then another important thing is that enthalpy. Enthalpy also one physical quantity. It is symbol is H. And it is also one extensive property. It is also extensive property. Eccentric nature. and also it is a state function. It is also a state function like internal energy. Same enthalpy cannot be calculated with accuracy, but the change in enthalpy can be calculated. H2 minus H1 only it will be calculated in the form of heat change. Like internal energy cannot be calculated, but change in internal energy calculated in the form of heat change for degree rise of temperature or drop for degree fall of temperature. How much temperature decrease will be divided, then how much heat change takes place. Here similarly, del Q by del T at constant pressure. This is the main important difference. So enthalpy change is determined at constant pressure, and your internal change can be calculated at constant value. Both related to heat change. Heat change for a degree temperature, heat change for degree temperature, but condition is at constant pressure. This is a constant value. So this is the internal energy, enthalpy, work done, heat. Both are the different physical quantity, but it has been observed that enthalpy change of any system is equal to its internal energy and product of pressure and volume. If you write this one, this is what relation between H. That means change in enthalpy is equal to change in internal energy plus change in work done. That is P del V. This relation also we can remember. Here what happens, that enthalpy change always greater than internal energy. That means if a system is absorbing heat, at a particular temperature, so amount of heat change takes place per degree change in temperature at constant pressure is more than the amount of heat change takes place per degree change temperature at constant. That means if the system is absorbing heat at constant pressure and constant volume, the amount of heat absorbed in case of constant pressure is more than the constant volume. So this is very important, that relation between del enthalpy change and internal energy change. Both related to heat, but how much heat change takes place at constant pressure and constant volume. But it experimentally proved that enthalpy change at constant pressure is greater than enthalpy change at constant volume. That means heat change at constant pressure and heat change at constant volume. This amount is the amount of heat is more. So this is regarding the relation between enthalpy, internal energy, then what is heat, what is work done, and how the work is done for the expansion of the gas isothermally and adiabatically and reversibly. This is ideal gas, reversible change and isothermal change. This work done is W is equal to, this is reversible work done, R in D, reversible work done is equal to minus 2.03 nRT log P1 by P2. What is N? Number of moles. R is the gas constant, T is the constant temperature. So this is regarding the relation between different physical quantity and its expression. Okay, next class we will discuss regarding the laws of thermodynamics. Okay, thank you all.